Hello everyone. This video is about the Knewton Alta assignment for section 2.2 part 2 called Application Problems and the Division and Multiplication Properties of Equality. So in this video I'm going to be going through a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the structure is the same. So I'm hoping that watching me do these here will help you in some way when you work on the assignment on your own. Alright, so on the assignment page you'll see the title, the mastery bar telling you how far along you've gotten. You can take a look at all the objectives. Looks like there are only 2 objectives for this particular assignment. And under the current objective, there is a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button, right? This is for instructors only. But you will have a more instruction button if you're ever struggling with a topic or a question, or would just like to do some further reading on the topic. Click on this. You'll be taken to a page with some reading or some videos or both related to that objective, and you'll also be given questions related to that instruction, and completing those questions will progress you through the assignment. So you could click on more instruction for every single question if you wished and work through the assignment that way. Alright, so the first objective I'm looking at here: translate an English sentence to an algebraic equation and solve using division and multiplication properties of equality. Alright, so we're asked to, translate to an equation and solve the following. The quotient of k and 22 is negative 66. Alright, so I'm going to do this so you can see the sentence still on the computer, and hopefully you can see my hand and my paper right here. Now when you see the words, quotient of, or the word quotient, that means that division is going to be involved. A quotient is the result of a division problem. And there are other words that will imply division, but I'll leave it to you to go to the more instruction button and take a look at the instruction they have to provide, and they'll give you a little list of some common words that are used for division or multiplication, addition, subtraction. So it says the quotient of k and 22. So that would be k divided by 22. That's a way to express the quotient of k and 22. Is, and you saw this in section 2.1 part 2, the verb in the sentence is usually going to represent, the equal sign. Is, and then the other side is just simply negative 66. Pardon me. And then we're asked to, solve this equation now. Right, so let me make the paper bigger. And all I would need to do is multiply by 22. Right, k would be equal to negative 66 times 22. And let me break this up. This would be negative, right? Now 66 is 6 times 11. 22 is 2 times 11. 6 times 2 is 12. Times 11 would be 132. And then times 11 again would be 1452. So negative 1452. Now if you had a calculator you could use it as well. I don't really care. You can do it without one though. You should be able to. And then don't forget to check your solution. When I plug in negative 1,452 in for k, is that divided by 22? Is that equal to negative 66? And it should be, and it is. I can see that right now. It would be, but don't forget to double check your work before submitting it. So the value of k here that they're talking about is negative 1,452. And submit. And then after you submit a question, right, submit an answer, it'll tell you if you're right or wrong, then give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why you were right or why you were wrong, and maybe you can learn from your mistakes for future questions. Great. Alright, the next question. Still in the same objective here. Alright, so here we go. Let me just do the same thing as last time, where I have you can see the sentence in my paper. And we're asked to translate and solve the following. The sum of 9/10 and g is 2/3. So 9/10 is 9 over 10. Right, that's 9/10. The sum means you're adding. Right, the sum of 9/10 and g. So 9/10 plus g is, right, equals 2/3. 2 divided by 3. And then we're solving this equation for g. Now you saw in my section 2.2 part 1 video, me solving equations involving fractions, which you could do in a couple ways. Now this one, you don't even need multiplication or division. To get g alone, I just need to subtract 9/10. Right? So g would be 2/3 minus 9/10. Now where the multiplication I think would come in is here. I can't add these or subtract these right now because they don't have the same denominator. Remember, to add or subtract fractions, you must have a common denominator. Now the least common multiple of 3 and 10 is 30. So I'd multiply this first fraction, this 2/3, by 10 over 10. That'll give me a denominator of 30. And the second fraction, the 9/10, I'll multiply by 3 over 3. That'll give me a denominator of 30 there as well. Now, so 2/3 is the same as 20/30 minus, and then 9/10 is the same as 27/30. And now that I have a common denominator, we can subtract. G equals 20 minus 27, so negative 7/30. Right? That common denominator stays. And 7 and 30 don't have any common factors, so that's as simple as that gets. G equals negative 7/30. And this really should have been in the addition and subtraction section, but here we go. Great. Alright, next question. Alright, now we're switching objectives. Use the division and multiplication properties of equality to solve application problems. Whenever you see the word application, usually means you've got some sort of word problem to solve. And you saw this in section 2.1 part 2 on application problems with addition and subtraction. I'm going to approach these word problems in the same way every single time. You read through the problem, you ask yourself, what do they want? What do I not know? And you call that something like X or Y or Z, and then you translate into math. Translate the sentences into math using the letters you've set up, the X, the Y, the Z, whatever. and solve the resulting equations. So I'm going to be doing that here, pardon me. So here, Bill notes that his apple tree is probably going to represent equals 4/5 the size of his pear tree. His apple tree is 4 meters tall. How tall is the pear tree? So once again, hopefully you can see the question upper left and my paper in the lower right. So again, what's unknown here is, how tall is the pear tree? The height of the pear tree is unknown. And instead of writing out the height of the pear tree every time I want to use it, or talk about the height of the pear tree, I'll just use the letter H for height. Or again, you can call it X, you can call it P for pear tree, whatever you want. So now that I've figured out what they want, I called it something, we go back and really take the only couple bits of information and make an equation out of it. And that's where my cursor is floating around right here. So his apple tree, the height of his apple tree, which we know is 4 meters. So the left side, I'll put 4 meters, 4. All right, 4. That's the apple tree's height is equals, and then the other side of that is 4/5 the size of his pear tree, right? The height of the pear tree. Now 4/5 of, usually the word of will imply multiplication when you say it's a fraction of something, a percentage of something. Usually implies multiplication is happening. So, the apple tree, which is 4 meters here, is 4/5 of times the height of the pear tree. So 4/5 times H. And then we're solving this equation for H. Now you can multiply by 5, then divide by 4, but or you could say that to get H alone, I would divide by 4/5. But remember, dividing is the same as multiplying by the reciprocal. So dividing by 4/5 is the same as multiplying by 5/4. And I do that on the other side as well. Here the 5's are gone, the 4's are gone. You have the height of the pear tree, H, by itself. And over here, just the 4's canceling up with 5 times 1, that's 5. Or 20 over 4, right? Multiply the numerators, multiply the denominators. 5 times 4, 4 times 1. 20 divided by 4 is 5 as well. And that was meters, right? This was a height in meters. And remember, H represents the height of this pear tree, right? So the pear tree must be 5 meters tall. And that's what we're asked to enter, right? So back here, now they already wrote the word meters, right? So don't write word meters, just write the number, 5 meters tall. Great. All right, they used the letter P for pear tree. Right, I used H for height, whatever. Right, you can call it X if you want. Doesn't matter, as long as you know what it represents. All right, so same objective, another word problem. So here, Lindsay fills up the gas tank before beginning a long trip. When the gas gauge shows that she has used 3/8 of a tank of gas, she has driven 165 miles. So how far could she expect to drive on a full tank of gas? Now, this is a thing you can do in a couple ways, right? A couple ways. Let me go so you can see the problem still. All right. So again, the distance traveled on a full tank of gas, that's the unknown here. That's what they're asking us for. Distance traveled on a full tank. Alright, so I'm going to call this, d for distance. Right. Whatever, again, you can call it x, whatever you want. So now you can set up something called a proportion here. I know we haven't really talked about proportions, but a proportion is where you have two ratios set equivalent to each other. Two ratios equivalent, two fractions equivalent. So I could set up the miles per gallon ratios for the gas she's used, and then for a full tank. All right. Or I guess miles per tank. Let's do that, because we weren't given anything, and we weren't given gallons here. We were just given tanks of gas. So for instance, she traveled 165 miles per the 3/8 of a tank. All right. And we can simplify this fraction if we wish. Dividing by 3/8 is the same as multiplying by 8/3. So we could simplify that in a bit. And this ratio should be equal to the d miles that she travels on one tank. Which, if you think about it, you could also think of it this way. You could say that 165 miles, that she traveled on 3/8 of a tank. Well, if that's 3/8 of a tank, then that's 3/8 of the distance she would travel on one tank. If you multiply by 3/8 here, right? D over 1 is just d. Multiply by 3/8, you get this equation. So, either one of these setups is perfectly fine. And now let's solve this for d. Now, I already kind of have it solved for. Right. Up here, d is by itself. D divided by 1 is d. You divide by 3/8, and like I said, dividing by 3/8 is the same thing as multiplying by 8/3. So over here I'd have 165 times 8/3. You got on the one side, 8s are gone, 3s are gone. You got just d. And over here, 165 over 1. 3 goes into 165 55 times. And then basically you're left with 8 times 55, which would be 440. And that's in miles, right? The distances were given in miles. So, if she traveled 165 miles on 3/8 of a tank of gas, she would travel 440 miles on a full tank. I hope that makes sense. Yeah, same kind of thing there. You read through. What do they want? What don't you know? Call it something like d or p or x or whatever, and then translate your problem into an equation and solve it. All right, so they called it t instead of d, whatever. But they ended up with that same 3/8 times t equals 165, like I had with the 3/8 times d equals 165. Right. And please read through the answer explanations. Maybe it'll make more sense if you're reading what they're doing. All right, so now we're back to the other objective on just translating and solving. So once again, I'll put this up with my paper so you can see the question. Alright, so this is the difference, right? The word difference implies subtraction. It's not just the word of, it's difference of, right? So subtraction. The difference of p and 1/6. So that's p minus 1/6. There's the difference of p and 1/6 is, right, equals 2/3. There's the fraction 2/3 on the other side. Now again, I don't know why this is in the multiplication one. Because I can just solve this by adding. You know, to get p alone, we would just add 1/6. Right? So we have 2/3 plus 1/6. But I do need a common denominator. I can't add or subtract without the same denominator. I'd have to multiply 2/3 by 2/2 to get the same denominator as this, to get a denominator of 6. So we get p equals now this is 4/6 plus 1/6, that'd be 5/6. And there you go, there's the value of p that would satisfy this equation. Right, 5/6 minus 1/6 would be 4/6, which is equivalent to 2/3. That works. So 5/6. Alright. And then looks like, based on our progress here, just one final question in this translate objective. And another one where you don't really need multiplication or division. But there are fractions involved. I think that's why they're having this in here, because you do have to multiply to get a common denominator. But you're not using the multiplication property of equality to do that. So maybe I'll send some feedback to them. I don't know why these problems are exactly in here. But anyway, let's do them. They're in there now. So the sum of 2/5 and f. So 2/5 plus f, right? That's the sum. Sum is addition of 2/5 and f is, right, equals 1/2, right? 1/2, a fraction. And this should again be pretty simple to solve for. Solve for f. I'd subtract 2/5 from both sides, so we have f alone on the left equals 1/2 minus 2/5. But then we need a common denominator. I'd multiply the half by 5/5 to give it a denominator of 10. And the 2/5 I'd multiply by 2/2 to give it a denominator of 10. So we have f equals, this is 5/10 minus 4/10, that's 1/10. And that's a simplified fraction. It doesn't simplify any further. There's your solution. And again, you can check that. 4/10 plus 1/10 is 5/10, which would be a half, right? You'd have a half equals a half. That works out after checking mentally. Alright, so that's what I'm going to enter, 1/10. Alright, so that objective should be done. And the remaining problems will be those word problems, application problems. Alright, so here it says B, or I'll say B, earned $11,700 commission for selling a house, calculated as 6/100ths, or 6%, of the selling price. So what was the selling price of the house? Right, what was the selling price of the house? So once again, I'll do it so you can see the problem. So again, the selling price of the house is what's being asked for here. I'll just put selling price, and I'll call it something. I'll call it P for price, or S for selling price, or X, whatever you want. And then it says B's commission was $11,700, so $11,700, and this commission was calculated as, the verb, 6/100ths of the selling price. 6/106% of times, right, the selling price. So 6/100ths times P. All right, so now we're solving this equation for P to get that selling price. Now you can reduce 6/100ths to 3/50ths, but I'll leave it this way because working with 100 is actually quite simple. Right? Working with powers of 10 is nice. So I'm going to multiply both sides by 100 over 6. The reciprocal of this, right? Same thing over here. Multiply by 100 divided by 6. And then really we just need to know how many times is 6 going to 11,700. Alright, so over here the 6's are gone, the 100's are gone. You got P alone, so I can get the selling price. And I'm just going to do this here. Take 11,700, divide it by 6. Goes into 11 once. With 5, then goes into 57 9 times. Right, 9 times 6 is 54. 3, 30, 5, 30, and then a bunch of zeros after that. So it'll be 1,950. Alright, so this goes into this 1,950 times, but then that's getting multiplied by 100, so 2 more zeros are going to get added. So $195,000. Alright, that was in dollars. That would have been the selling price of the home. Okay, and that's what I'll enter. So we got, and they already had the dollar sign, right? Don't need to add that. So $195,000. There's the selling price of this house if she earned, 6% of it, and it was 11,700. All right. All right. Next should be one final question based on the progress. So Jenna bought a coat on sale for $120, which was 2/3 of the original price. So this is very similar to the selling price one. Very similar. What was the original price of the coat? All right, so same deal. I'll pull up, make sure you can see the problem. And yeah, the selling price, what was the price of the coat, or the original price? What was the original price? Because the selling price was, it was on sale, right? Pardon me. So again, I'll just call it P for price. I wouldn't call anything O if I were you, because you'd probably easily confuse that with the number 0. Or X, right? X is always a good one, X, Y, Z. Anyway, original price I'm calling P dollars. Now the sale price was $120, and they're saying that this sale price of $120 is 2/3 of the original price, 2/3 times the original price, 2/3 times P. And I'm just solving this equation here. So the sale price, $120, was 2/3 of the original price. And then I just divide by 2/3 or multiply by 3/2. Right? Dividing is multiplying by the reciprocal. So here I got P alone. Great. Now I know what I can figure out what the original price is. 2 goes into 120 60 times, and 3 times 60 is 180. So the original price of the coat was $180, right? And they took 1/3 off of it, right? Sold it for 2/3 of the price. So, and they got the dollar sign already. Don't need to type that in. Wonderful. All right, and again, please read through the answer explanations. Hopefully understand what's going on. And that should be it for this preview version of this assignment. Now, as I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same. The structure is the same. So hopefully watching me do these here help you in some way when you work on the assignment on your own. And thank you very much for watching.